Hello, folks. So today I'm going to talk reasonably high level about modern implementation of TLS in enterprise. No one person controls everything. In fact, the infrastructure controls you most of the time. So who am I? Well, really, I'm nobody, as Ron noted. But if I must, it turns out I did, loaded up calc last night. It turns out I've been doing internet crap for 19 years. I feel like an ancient person, but I'm young in my department. Who'd guessed? So I did CS at U of M. I went on to system administration to pay for my degree, and did a bunch of stuff after that. Some of you know it, some of you don't. Doesn't really matter. And I was doing shadow InfoSec for a long time. Basically, the annoying guy in departments that you're doing it wrong. So now I get to tell people, yeah, you're doing it wrong, but how can I help you fix it? So the picture was made by a friend of mine because I got a reputation for being the guy that says no a lot. And so I embrace it. I say no lots. But now I say no, but how can we turn that into a yes later? So what is TLS? Well, everybody in this room knows what it is. It's essentially, we all call it SSL. We all use the term SSL. The term SSL should just die in a fire. Preferably now, preferably even 10 years ago. Essentially, you can't have a conversation without context, and the context for SSL is broken. People understand it, but they all understand it wrong, including me. Most of the time, I screw it up. Essentially, what TLS is, it's a channel for communication that does two things and two things only. You get encryption, which is 99% of what people understand TLS to be, and trust, either federated or consolidated. But trust is just as important, if not more important, than the encryption. We just don't talk about it, or we don't leverage it properly. So let's not talk about SSL anymore. If you want to use the GNU Linux crap, that's fine. Use TLS/SSL, or just say TLS. When people say SSL, try to steer the conversation away, because like I said, you can't really have a conversation when people understand things differently. So start with something fresh. Well, I've seen a lot of implementations. I've implemented a lot of bad ones, and the only insight I had was, for TLS, it's the screw we hammer into literally everything. Well, screws, definitely not the right tool for this job. The hammer, well, because we love smashing things. But the end result is you get a broken piece of wood, or you get a broken whatever you're trying to hammer this into. So yes, you get the little check mark that says encrypted, but you're not getting much else. In fact, you're losing more in terms of functionality, support costs, you name it. You're not providing anything other than pain for the people behind the scenes. So we have lots of problems. Mostly, they're just configuration and understanding of how to apply TLS to things. Most of the time, it's just a checkbox. Vendors like to provide you one-click install, also one-click fail. So lots of things, especially middleware, will enable client authentication, but not tell you how to use it. So you've got sessions or two servers talking to each other using TLS as the session transport. And the first step is, okay, try to authenticate the client. Server's like, I don't know, what do I do with this? I don't talk that way. Do server authentication only. So you've just wasted a bunch of the handshake time, and you've provided no value. You've produced great error messages, but nobody looks at those anyways. We also see people using SAN certs, or wildcard certs, or basically using certificates to get around their understanding as opposed to applying them appropriately. A common thing I've seen is creating a SAN cert, which is the host name, fully qualified domain name, and then the short version, i.e. the domain name chopped off. that's just to get the little green check mark, but you've just given away all of your infrastructure at that point, because anything dot nothing can be matched by anything. So what exactly are you getting out of that certificate? Nothing really. Wildcard certificates, star.anything.anything, well, you get encryption, but you've just thrown trust out the window. There are really good use cases for it, like farming and load balancers that have farms of services underneath. But most of the time, you can get away without using it, such as using a SAN certificate with the name of the specific host, as well as the virtual IP, or virtual host name. Another really expensive thing that was popular is to use third-party CAs for internal stuff. Why bother? Why are you spending hundreds of dollars a year on certificates that the outside world will never see? Is it because you don't trust yourself? Well, in many cases that's true, but in my experience, auditors love to see external trust, like it gives you something you don't already have. So you need to leverage your internal CAs. If you don't have one, well, you probably do, you just don't know what it's called. If you have AD, you have an internal CA. You just don't know you're using it. Another thing that's a little bit more common now, because browsers love to complain, is serving your endpoint certificates without the full chain. The certificate is good, but your browser will crap all over it, saying, I don't know this guy. Well, it really does. It just can't get the full chain from the connection to compare to its local trust store, so it says, you did it wrong. I see this time and time again. It's the easiest thing to mess up. And self-signed certificates. You find any tutorial about how to enable TLS on anything, and it will tell you how to create a self-signed certificate, but it won't tell you how to use it or when it's appropriate. So it's pretty much never appropriate, because developers use it to save time, because asking for anything is, well, wasting your time, or it takes 10 years to get a certificate. So we'll just use self-signed and call it a day. Well, then you don't get any of the trust functionality that TLS offers you. So if you have a CA, make sure you can provision them really fast to have developers actually use your infrastructure as opposed to work around it, which is what I did for most of my career. So the other big challenge in gigantic corporations, especially ones that take your money or know lots of very sensitive things about you, is regulations. For me, they're a pain in the ass. But I also like that they're there. They keep the organization in check, but not necessarily in a useful way. Regulations tend to be super vague. You must have an X, or you must do X, and then P, and then Q. And yes, we know those don't all fit together, but you have to do them anyways. So traditionally, like at least what I'm seeing now and what I'm living through now, is that regulations are telling us we must use technology X. So expensive spear sharpeners for the dull edge of the spear. We're not poking anybody with it. We're not getting any attack surface reduced. We're just implementing technology and hoping that it does something good for us. In many cases, they can. The regulations are good. The problem is that we have to find a way to integrate it into our infrastructure so that we're not just wasting time and money. So, for instance, SSL inspection. I've seen a number of products that will say, yeah, we do TLS inspection, but the only cipher we support is null with null and null. Well, that's great. You don't get encryption, you don't get trust, you get nothing. So what's the value of your product? So how do you integrate this stuff? Well, you have to, because regulations say you must. So let's think about it a little differently. Let's first talk about WAF. WAF is generally a new thing, and by new I just mean that people are now using them. Exactly. So think of it as a load balancer with grep, essentially. There are some learning facilities, and it can be very useful, especially in giant infrastructures that don't change or that move at a glacial pace, because you can bolt this stuff on and then gain a little bit of time to remediate the back end. It's not really how the salespeople will like to sell it to you, because it's just like, oh, bolt this in and you're good and you never have to touch anything. No, it's a great starting point. And for applications, especially support folks that are just learning to use that 20-year-old mainframe application that someone wrote that retired 5 years ago before you started, it allows you the ability to understand what your application does. The profiling and self-learning can be extremely valuable, figuring out how exactly your application is doing something, as opposed to, we just run it and we deal with complaints as we get it. So it gives you a little bit of insight if you apply it appropriately. So while WAFs are mostly terrible, if you just think about them a different way, they can be extremely useful. The other really big challenge that browsers right now are ramming down everyone's throat is perfect forward secrecy. Well, Diffie-Hellman's a gong show at the moment, but at the same time, it is very useful if you use non-standard curves and you decide to use non-common primes, like not the one in the box, generate a 2K or higher one and apply it to your web server or application server. They do very good things. The problem is, you get the nice political scare tactic that all of our inspection is now dark. We can't see anything. We have no intelligence. Well, you didn't in the first place, but now you have even less. So the best part about going blind is that you don't even know you're blind. All of your inspection stuff will go, it's just traffic I can't see. It's got to be good, right? Pass it on. I haven't seen a tool yet, or an inspection service that will go, I can't decrypt this, or I can't see this, let's send an alert. That's rife for giant amounts of false positives, but if you're wanting to be able to inspect anything, knowing what you can't inspect is probably where you should be spending your time. Finding tools that let you filter that out, that's very, very difficult. So in enterprises and large infrastructure, we tend to want to paint things with very large brushes. We have one color and one really large brush, and everything gets painted with it. Why? Efficiency, or money, or we're too lazy to learn. So how do you deal with this? Do you just consider all of your encrypted traffic collateral damage and just not inspect it? Or do you think through the problem a little more? So this is a typical infrastructure that you would see for applications in N-tier, enterprise, insert your buzzword here. I would call this highly failable architecture. Try to go from the tubes right down to your application server with a single path twice? Yeah, it's not going to happen. Not only is every vertical line a different group in your organization, but you can't tell what path any packet is going, either because it's natted 7 ways from hell, or someone forgot to turn on X-forwarded 4 in a proxy. So you can't tell where things are coming and going. So you can have all the inspection in the world, but all you're looking for is application bugs. You're not really seeing how things are running. So how can we change things and move some of that inspection to get some value out of it, but also have nice and clean security for your customers, things that you want to face? If I want to talk to a company, I would prefer that they put a little bit more effort into securing the front end, and then the back end I really don't care about. It's going to be squishy. As long as it's not accessible, well, I hope they solve it, but in reality, as a consumer, I don't really care. So how can we leverage that? Well, we can do the stupid thing and just encrypt everything. If you ask anybody in an ISO organization, can I do this? Can I use this protocol? The answer will be yes. Oh, okay. Well, that doesn't solve any problems for me. In fact, it creates more. Now my inspection stuff, this junk here, sees nothing. So I either have to move it around, which again, it will still see nothing, or I can just say it's collateral damage, but I'm secure, according to Qualys. I got my little A+, that's got to mean something, right? Well, let's try it again. Let's use SSL termination. Previously, it was a technique used because TLS is slow, encryption is slow. Well, it's not. But we do need to put a nice, clean, secured interface to our customers. So let's do TLS here, the buck stops here, everything else is widely open. Well, that solves one problem, but introduces 3 more. Problems it introduces is, yes, you get inspection, but you've lost trust in your infrastructure. You have no means of determining exfiltration of data because you've only got one thing in, and you're not really talking. You're just letting things out without even looking at it properly. So that's not a solution either. Now, notice that I'm just drawing boxes. I'm not really changing the infrastructure, except in this case, I'm putting the IPS behind the control point, where the control point is like a WAF or a load balancer or some other form of reverse proxy. So that's a subtle change. It allows me inspection after that point, but I've only solved one of my problems. So that's not good either, so let's try again. So here's the interesting thing. If you disable PFS, or perfect forward secrecy, Diffie-Hellman, you name it, choose your acronym of the day. Essentially, if you hide it, or if you disable it, you get your inspection back. You install your private keys on your inspection devices, you install your certificates and private keys on inspection devices. Sorry, that is a really important point. And you get all your inspection back, but let's use the TLS Trust Layer a little bit better. So what does the trust layer mean? Well, a certificate authority is a person or a thing or an organization that provides you with certificates that says this one is good, this one is not good. You have an external one for people that don't trust you, which is the world, and that's the way it should be. But you also have an internal CA. And use that internal CA to provision all your internal infrastructure. And your demarcation point is the load balancer WAF layer. We're just assuming HTTP, but this will work for all TLS style implementations. So what you get now is you can implement mutual authentication on your back end. So that wasted client certificate configuration, well, now let's use it. Let's say I will only talk to things that I trust for the CA that I provision. All of the default ones, we'll just remove them. So when something you're not expecting talks to this layer of your application, it fails. And it does exactly what it's supposed to do. It fails, we look at the logs, we remediate, call a cert, do whatever you need to do. But at least now you have that intelligence. Before, you just assumed everything was great because no one was screaming at you. So just by that subtle change, we've solved not only the problem of my inspection stuff goes dark, but we've also increased the availability and reliability of our back-end infrastructure. The only thing is you got to train people, and that's really, really hard. Well, the other thing, since we're talking about web-based stuff, what about the fancy new headers like STS, HST, or essentially HSTs, public key pinning, all that other good stuff? Well, that's great if you're talking with browsers, and you should use them. But they also introduce problems. Specifically, public key pinning is great, but if in the previous infrastructure, each one of these lines or each one of these columns is administered by somebody else, how do you know when you replace the certificate that the pin changed? Well, that's a great way to create an outage. So you need a lot more coordination there. You need a lot more process. Are you getting the benefit out of pinning that you would by not using it at all? And you don't need pinning for STS to work. It's preferred, it helps, but it's not necessarily required. So use it appropriately and then put it in later after you worked out the process. CSP, it's great if your browsers adhere to it, but Java applications don't. So it also breaks things. Let's just say you have hundreds of applications in your enterprise, odds are a huge portion of them are third party. Do you know how they work? Do you know how they're implemented? Do you know if they're using frames or third party cookies or content type negotiation? You don't know. So implementing this stuff on your WAF or on your head end, it's great, but expect things to break. That's okay. Failure is good. You just have to know what to do with it and be able to work through it. So what are some solutions? Well, the first thing, trust between application layers is by far the most common thing I see as problems. If your Java logs have anything that say PKIX, odds are you didn't include your CAs in the trust store. I see this so often, I wrote a script called defang JVM, which just looks for every CA certs file on a system and injects our common trust CAs. I also use it to disable export crypto, because a lot of three-letter companies will ship things to Canada with export crypto enabled and not tell you, which is fun, but you have to really, really be looking at things to catch it and then remediate it. No cipher suites available. So if you get really down in the weeds and you're like, I'm going to lock this thing down 100%, you're going to break it, and the error message you're going to get is either no protocols available or no common cipher suites. So in this one, it's more or less trial and error, because most of the logs won't tell you what ciphers it tried, and you can use OpenSSL S client or Wireshark to see what the endpoints are negotiating, and then do your own overlap. But most of the time, it's because you've disabled SSL v3 for some really old app or some really old appliance, and it won't get updated. So first check that, then go deep down with those two other options. When the whole public chain issue, when you serve the chain along with your certificate, that's pretty recent that things fail, because usually it would look and try to validate up the chain on its own. By it, I mean the client. Now the client's saying, well, I'm only going to validate against myself once you tell me what I'm going to validate. So it looks at the chain, makes sure that you've served the entire chain, and then compares it to its own trust store. The communication for that was really, really bad. So a lot of sites broke really, really quickly. I'm still seeing to this day. I'm still trying to get a piece of infrastructure to get updated to send the full chain. Like, everything is right. All the configuration is correct. It's just missing the chain bundle. And it's a very hard thing to communicate, because, oh, it validates for me. Well, try going outside for a bit. The world is actually different than what you see in the window. So, and finally, the usual browsers complaining about invalid names. Well, this is a good thing, because, well, like the previous talk from yesterday, DNS fuzzing, man-in-the-middle attacks, these errors are there for a reason. Now, if you've gone through the due diligence of set everything up appropriately, these errors are something for you to action, not mitigate by throwing in a sends or a wildcard or something just to get that little checkbox and the business happy. Look at it. Take the time. Don't just do quick fixes. Well, so how do we fix these problems in enterprises? Well, essentially it's consultancy. You have to find someone in your organization that tries to understand this stuff and then educate everyone from developers to operations staff. Take the time to walk people through, listen to their problems, and try to help them not only be compliant, but show them the benefits of being compliant without any effort. Like the previous example of throwing a WAF in front of something to get Qualys to give you an A instead of a C, that has value. You can give that for almost no effort, so do it. The more value you provide someone, the higher the probability that when you say they're doing something wrong, they'll listen to you. Because if all you say is no, well, eventually people are going to start ignoring you. So turn that no into a yes. And make sure that you provision things for developers faster than they can break it themselves. Finally, don't be afraid of mutual auth. It's super, super powerful. The problem is nobody really uses it. Some good resources. Ivan Ristik's book, Bulletproof TLS. It's expensive, but it's really well written. It's focused on browsing and not the CA infrastructure. That's a big hole in the market right now, but it's better than nothing. In fact, I recommend it highly. OpenSSL S client and S server, they're the most important tools in my toolbox. I use them more than I use Wireshark or anything else. They're also, if you want to see how things are changing on the real internet, the Trustworthy Internet Movement basically scans for stuff and provides reports. It's a nice high level. It's saying, are you going in the right direction as everyone else? And then the CA browser form. CAs are notoriously difficult to manage, and they're even worse to implement. So use the standards other people develop for you. Oh, I got the deck online. I didn't say most of what was on the slides. So feel free to take a look at the slides more in depth. You can email me, use the twatter or whatever. Or if you don't want to listen to me, get some better headphones. Are there any questions? Okay, typically when you're browsing, you authenticate the server doesn't authenticate you. It's not just a bad Russian joke, it's the way we browse the internet today. Mutual authentication bridges that gap by saying, I'm gonna apply a certificate to my clients as well as servers, so not only do I authenticate the server authenticates me. Yeah. Right, yeah, you wouldn't hand them to them, you would install them in workstations. You would deploy them via AD or whatever. It also makes SSO trivial to implement, where SSO is single sign-on. Well, export-grade crypto is essentially those TSA locks that Adrian talked about last night. Do you have encryption? Yes. Oh, that's great. I have keys, I have locks, but they're really crappily implemented, so they can be broken in real time, or they're easy to inspect. So for regulations, that's great, because I can break everything, and I give this false sense of security to users. The US had this thing called an export policy that said strong crypto is not allowed to be sold from the US to anywhere else in the world. Well, everywhere else in the world said, screw you, we'll just sell it instead. So it solves nothing, but gives US regulatory bodies at least some form of useless comfort. The problem is that a lot of third-party software and a lot of infrastructure is sold from US companies, and they enable this export encryption by default and make it really difficult for you to turn it off. It's a huge problem, and it's getting worse. The only way to solve it is to start keeping vendors to task. So going, I need to disable this kind of cipher suite. Why doesn't your application let me do it? And then not buy their crap when they won't give you a satisfactory answer. Unfortunately, it's the only way to do it. It's not very good on the business side, because now you're slowing projects down, but it's the only way to get rid of this export problem. Is that a good answer? Okay.